Okay, in this video we are going to continue talking about change in dimensions, So what happens to a figure after I dilate it? What happens to, we obviously know what happens to its sides, we just multiplied them by the scale factor. But how does that affect the perimeter and the area? That's what we're going to continue talking about today. I think we've got a pretty good understanding of what exactly happens. So today we are going to just kind of manipulate some formulas to help us take those shortcuts of multiplying the perimeter, the original perimeter, by the scale factor, and multiplying the original area by the scale factor squared to find those new perimeter and areas for our images. So just kind of recapping what I said there, the new perimeter is found by the original perimeter times the scale factor. And the new area is found by the original area times the scale factor squared, which just tells me that's the original area times the scale factor one more time. And I want to point out again that when I'm working with perimeter, my base units are to the first power. And notice we only have one scale factor. When we work with area, our units are to the second power. Area works with units squared. We're in 2 dimensions then. So we'll have 2 dimensions of scale factors. When we work in 1 dimension, we're working with 1 scale factor. We're multiplying by 1 scale factor. And when we work in 2 dimensions, we are multiplying by 2 scale factors. Now, it's not a coincidence. One more thing I want to remind us about is to find the scale factor. Remember, that's the letter K. We take something from the image, or the new thing. I'll put image. Use that vocabulary there. And we'll divide it by something from the original, or the preimage. Something new, something original, NO. Alright, looking at that first example then, here's what I'm talking about, problem solving. The first thing I notice is that today I have an area instead of 2 side lengths. So we're given the area of this shape. This is the old area is 60 inches squared. And we want to find all of the other dimensions here, the old perimeter, the new perimeter, and the new area. Before I can even find the old perimeter, I have to know the other side length. To find that missing side length in the rectangle, this one, that I'm highlighting in orange, I want to remind us, point out, we can use the area to find that. We know that the area is equal to the base times height because this is a rectangle. Well, the area is 60. I can say that the base is the unknown side, okay, and the height would be 5. You could have flipped that and said that the base was 5 and the height was the unknown thing. Well, to isolate that b, we would undo the multiplication by 5 by dividing by 5. So now I've got 60 divided by 5 on the left, which is 12. b times 5 divided by 5. Those 5's make 1, so we're left with 1b on the right. This tells us that 12 is the base now. This is 12 inches. Likewise, this is 12 inches, and this is 5 inches. Now I know all of my side lengths, so we can go ahead and find the perimeter. The perimeter then, for the original perimeter, or the old perimeter, would be 5 plus 12 plus 5 plus 12 again. And when you add that up, you get 34. The original or old perimeter is 34, and we are measuring in inches. I hope I said it when I wrote it. I hope I said 60 inches squared instead of 60 inches. The area is 60 inches squared. I forgot to put my square on that area there. Okay, so I've got the original perimeter and the original area. Now I'd like to find the new perimeter in the new area. That is this shortcut that we remembered that we learned from yesterday. So we're going to try and use those shortcuts. Let's look at the new perimeter. To find the new perimeter, we would just take the original perimeter and multiply it by the scale factor. The original perimeter times the scale factor. That would be the original perimeter is 34 times the scale factor, which is 1/2. So half of 34, 34 divided by 2, 34 times 1 divided by 2, however you'd like to think of that. However you get the cookie, you get 17 inches. So the new perimeter is 17 inches. Now looking at the new area, to find the new area, we take the original area and multiply it by the scale factor squared. That's the original area times the scale factor again. One more time, that's the original area times the scale factor once more. So the original area was 60, so I have 60 times the scale factor 1/2 times the scale factor, again, 1/2. This is 1/2 of 60 is 30, so this portion here is 30, and 1/2 of 30 is 15, so the new area would be 15 inches squared. And just to kind of prove to you and show you what's really happening behind the scenes here with our shortcut, let's draw this rectangle. After we determined that this side was 12 from our area, after we determined this side was 12, we could have, instead of taking the shortcut, we could have used the fact that the scale factor is 1/2. So we would have had a smaller rectangle. The height of this would be 2.5. 1/2 of 5 is 2.5. And then 1/2 of the top base is 6. So 12, 1/2 of 12 is 6. So this would have been the new rectangle that we're dealing with. To find the perimeter for that, you would add all the sides. 6 plus 2.5 plus 6 again plus 2.5. You'd have 6 and 6 is 12, 2.5, 2.5 is 5, so the perimeter would be 17. Now the area would have been the base times the height, so 6 times 2.5, which is 15. Which is exactly what we got, but we didn't have to take the scale factor and multiply our sides by that, and then do the formulas. We could just remember the one formula. Perimeter, the new perimeter is original times the scale factor. The new area is the original times the scale factor squared. Let's look at some examples down below. And these examples are going to be almost exactly like this example we just worked out, except we're going to also have to find the scale factor. So to find the scale factor, remember, we are looking at something from our new, or our image, over something from the old, or the pre-image. I'm just going to assume something new is on the right. So something new is 24. So this will be 24 over something original. Its corresponding side is 12. So this is 24 over 12, which is 2. So the scale factor we are going to say is 2. Now here again, they've told us the original area was 168 feet squared. 168 feet squared. And I'm left to find the perimeter, and just like in that first example, I have the height, I don't have that base, so we'll remind ourselves area is base times height. Area is base times height, so 168 would equal the base times 12. We would divide by 12 on both sides, so we have 168 divided by 12 to get to this number here, 168 divided by 12, and that gets us 14. That side length then is 14. So when we find the old perimeter, we'll have 12 plus 14 plus 12 plus 14, and that gets us 28, and 24 is 36. Sorry, 56. Whoa. 56 feet. Now we're ready to find the new perimeter in the new area, which is super helpful because we don't have the other side lengths here. So the new perimeter will be, the new perimeter is just the original perimeter times the scale factor. The original perimeter, which is 56 times the scale factor, which is 12. 56 times 12, I don't want to, my brain is fried after today, so we've got 56 times 12, 672. That's perimeter, so my units will stay as feet. That was a lot quicker than having to determine what my other side is and adding all of those four sides up. Now we'll look at finding the new area. The new area is just the original area times the scale factor squared, which is just the original area times the scale factor once more. We're multiplying by the scale factor twice because area's units are in 2 dimensions. My original area was 168. So we're going to multiply by the scale factor times the scale factor again. Times 2 times 2. 168 times 2 times 2, or 168, we know 2 times 2 is 4, so times 4, 672. So the new area is 672. This is an area, so we're using feet squared. And now looking at the example to the right of that, the example is kind of identical, just with different numbers. So first things first, we'll find the scale factor. We take something new, 1, divide it by its corresponding thing from the original, 3, and that's the scale factor. 1 over 3 doesn't reduce, so the scale factor is simply 1/3. To find the old perimeter, before I can get started with that, I have to know what that missing side length is, the base. So I know this side times 3 will get me the area 27. That's 9. 9 times 3 is 27. So that's 9 inches there. The old perimeter then, the perimeter is 9 plus 3 plus 9 plus 3, which is 24. So the old perimeter is 24, and they told us that the old area was 27 inches squared. I'm going to go back in and add the old perimeter's units was inches. Okay, now we get to use that cool shortcut that we learned yesterday to find a dilated perimeter and a dilated area. So to find that dilated perimeter, or the new perimeter, we'll take the original perimeter and multiply it by the scale factor. The original perimeter was 24. The scale factor is 1/3. 24 times 1/3 is 8. This is measured in inches, 8 inches then. is the new perimeter. The new area is found by taking the original area times the scale factor squared. Area works in 2 dimensions, so the scale factor must also have 2 dimensions. Original area was 27 times the scale factor squared. That would just be times the scale factor again. 27 times a third, or 27 divided by 3 again. 27 divided by 3 is 9, and 9 divided by 3 is 3. So the new area here is 3 inches squared. Now looking at the middle row of examples, we have, this time we're kind of going backwards from what we just worked with. Instead of giving us the pre-images area and one side, they've given us the images area and one side. I'm going to start out by finding the scale factor. The scale factor will be something from my image over something from the pre-image. Something from the image is 35. Something from the pre-image is 7. So we've got 35 over 7 as the scale factor. 35 over 7 is 5. So our scale factor is 5. Notice that I can't start finding anything about my original image, but I can go ahead and start filling out information about my image. Well, the new area is 2,975 yards squared. I know the area in one side length, so if I wanted to find that missing side length, I just have to know 35 times what I've highlighted in orange will equal 2,975, which means 2,975 divided by 35 tells me that orange side. So we've got 2,975 divided by 35 gets us 85. This orange side is 85 yards. Now I'm all set up to find the new perimeter. This is the new shape, and I have both the base and the height of the rectangle. So I can add 35 and 85, 35 and 85 again, which is going to get us 240. The perimeter would be 35 plus 85 plus 35 plus 85, or 240 yards. What I'm going to do now is I'm going to work backwards. What we could do is going to be different from what I recommend doing. What we could do is say the new perimeter was the original perimeter times the scale factor. Well, we know that the new perimeter is 240, and we know that the scale factor is 5. So we're using that same idea when we found the missing side length. I have a missing number here in place of my original perimeter. I could divide both sides by 5 and solve for the original perimeter. That's 58. So 58 would be the original perimeter. Just because our brains don't work backwards 100% of the time perfectly, I think it's probably easiest if we only work backwards with the scale factor. So I can say I've got this 85. I know that we took a number and multiplied it by 5 to get 85. So 85 divided by 5 must get me that missing side length. 85 divided by 5 will get me that missing side length. So I know my missing side length here is 17. And now we're set up to find the perimeter and the area using the formula. This is how you can use the shortcut backwards to find the new perimeter. How can we use the shortcut backwards to find the new area? It's the new perimeter. To find the new area, we take the original area and we times it by the scale factor squared. So the original area times the scale factor times the scale factor. The original area was 2,975. Sorry, the new area was 2,975. We don't know what the original area is. Times the scale factor times the scale factor times 5 times 5. 2,975 is the original area times 25. Again, you can work backwards here. Just divide both sides by 25 to find the original area. 2,975 divided by 25 is 119. Just because that's a lot of working backwards with something that is brand new to us, I don't recommend using this unless this makes sense to you. I would much prefer that we, like I just did earlier, we work backwards. So I know the scale factor was 5, so this height times 5 got us to 85. So 85 divided by 5 gets us the height. 85 divided by 5 is 17. Now I can find that original perimeter. The original perimeter then would have been 7 plus 17 plus 7 plus 17. That's going to get us 14 plus 17 plus 17 is 48. And then the original area would have been 7 times 17. That's the base times the height. And 7 times 17, 70, 49, 119 yards squared. I spent a lot of time on that problem because I did it two ways. I did it working backwards with the new trick we learned, and I did it working backwards with the scale factor and just applying the formula for perimeters and area of a rectangle. I think that second way was a lot easier for us 8th graders. So in this next example, that's how I'm going to work it out. Here I've got two rectangles. I need to find the scale factor, old perimeter, old area, new perimeter, new area. The scale factor will be something new over my original thing. Something new is 10. Its corresponding original piece is 4 units long, or 4 feet. 10 over 4 is the same as 5 halves, or 2.5. 5 halves. Okay. I see that my new area has been given to us at 375 feet squared, along with one side length, which means I can solve for the other side length in this rectangle, because 10 times something gets us 375. So 375 divided by 10 gets us that missing side length. The missing side length then is 37.5. Now that I've got the missing side length, we can find the new area. The new area would be 10 plus 37.5 plus 10 plus 37.5, which gets us 95 feet. We're going to use the scale factor to work backwards from 37.5 to find the original corresponding side length to 37.5. So something here times 5 halves got us 37.5, which means 37.5 divided by the scale factor, 5 halves, gets us that side length there. 37 divided by 5 halves, 37 divided by 5.2, or sorry, 2.5, I believe that's 15. 37.5 divided by 2.5, I believe it's 15. Yep, 15. So we've got 15 as that side. Now that I know that side length, finding the perimeter in the area should be simple. The old perimeter would just be 4 plus 15 plus 4 plus 15. Four plus 15 plus 4 plus 15 is 38. And this is measured in feet. And the whole area would be the base times the height, or 15 times 4, which is 60 feet squared. Now you could use the scale factor to check here using the trick. The old perimeter times 5 halves would get us 95. The old area, 60 times 5 halves squared, or 60 times 5 halves times 5 halves again, would get us 375. These last two problems are just a couple of word problems. So I'm actually going to stop the video here to prevent this from being a 40-minute video. And I will put the word problems in a video all by themselves. This has just been more change in dimensions, just kind of problem solving and working backwards and manipulating what we know to find something new. If you have questions, comments, or concerns, please send me an email, a message on Schoology, or drop a comment on the video, and I'll gladly get back to you as soon as I can.